Hello everyone. In this video I want to talk about a few other important things in GD&T. One of them is called bidirectional tolerance zone. So it's a tolerance zone that is not symmetric. Then we have the between symbols for a profile. Then non-uniform tolerance zone, or you might call it unequally disposed, where you see the symbol U and then the all-around symbol. So what are these? First, start with bidirectional or a non-symmetric tolerance zone. So here, if you look at this picture down here, if you can see, for the position of the center of the hole, there are two positional tolerances. One is with 0.4, the other one is with 0.2. And the 0.4 is for this horizontal direction, and the 0.2 is for the vertical direction. So instead of the center of this hole be allowed to move 0.2, 0.2 in all directions, as you can see, in one direction the total deviation is 0.4, so 0.2 on each side, and the other direction is 0.2, so it's 0.1 on each side. So the area it is allowed to move is a rectangle as opposed to a square or a circle, right? And similarly here on these holes, you can see that, for example, for this hole in this theta direction, you have one positional tolerance, and then in this radial direction, you have another positional tolerance, okay? So again, here it's like a slot, basically. That's what it is. So if you want to have that, right, if you want to have that, how would you do it in SolidWorks? Well, here, this is SolidWorks, and I have added it for you here. So the way to do it is you go to Sketch and use a line, and then draw these four lines, two horizontal and two vertical, from the corners of the circle. And then for this vertical one, you add one, and then for this horizontal, you add what? Another one. So this is how to show a bidirectional tolerance zone in this case. The next thing is what we call unequally disposed, or unequal tolerance zone, which is kind of related to previous topic but not exactly the same. So here you have this symbol U, right, which talks about the fact that the tolerance zone is not perfectly symmetric about the shape. So here, what am I saying? I'm saying that, first of all, this profile is not on the entire circumference of the object. It's only between point X and point Y. So you see I'm using between symbols, okay? And then here, the only thing I have is just 0.8. What does it mean? It means if this middle curve here, this middle curve is the actual profile, right, then the tolerance zone is of thickness 0.8, which means 0.4 of that is above the actual profile, and 0.4 of that is what? Below the actual profile. So here this middle one is the actual profile, and then 0.4 above and below it, that counts for 0.8 tolerance zone. So if you don't put that U, that is symmetric. But if you say 0.8 and then say U and 0, right? So you add a U and then you add a second number. What does it mean? This time it means the true profile is what? The actual profile is this top one. Above it, I have no room for error, but below it, I have 0.8. So you see there is nothing above it, but below it is 0.8. So this is what we call unilateral tolerance zone. So you only have below the actual tolerance zone room for error, not above it. And exactly opposite of that is this side here. So say 0.8 U 0.8. What does that mean? This time your true profile is what? At the bottom of the tolerance zone, and 0.8 above it, you can have ups and downs, but nothing below it. And if you don't want it to be unilateral, like this one or this one, you can have bilateral case, but unequal, here you put a number that is what? That is like, for example, less than half of that or more than half of that, so 0.2. What does 0.2 mean? Again, it means this is your actual profile, and above it you have 0.2 for error, and below it you have the remaining, which is 0.6. Okay, so the number after you is always what? This is the number above the true profile. And then the difference between the left number and the right number is below the true profile. Okay, so we use that U symbol, we use a secondary number, and if it's not the entire surface, that sometimes it's not, you define points X and Y and you use between symbols. So this is between symbols and unequally disposed. Now, how would we do that in SolidWorks? So here, I have added point X and point Y with the note, and then this one. So let me do it again for you so you see that, right? So for that, you go to annotation, you click on the note, you make sure it has a leader, and then you click on the point you want. So let's say the start of this fillet, right? And again, let's make sure that we have the, let's do it again. Let's make sure that we have a leader for that. So not that one, this one actually. I clicked on the wrong one. So here you bring it out and maybe call this point X. And then you repeat the same thing and call the other point. Let's click here and let's start it at the beginning of this chamfer, right? So just this top profile. Maybe this one, call it Y. Okay, so here are points X and Y. Now I go to geometric tolerance and I refer it to the surface, and I want it to be a profile, and maybe 0.08, right? 8 thou, something like that. Now here you have to add that U and 0.02, right? 2 thou, 0.002. So for that, you see here, you go to offset zone, and here you click on U, and then you say what? 0.002, 2 thou. Then you can add datums, let's say A, B, and C. Right here, I didn't put A, B, and C, but you can if you want to. Right? And done. You see here, so you can make it unequally what? Disposed, and then you need to add what? You need to add the between symbol. So if you click here, this one in general has 4 options on the left, right, top, and bottom, right? This box, you see when you double click on it. Each one of these, when you click on this plus, you can add something above it, below it, and so on. So here I click below it, and then I say what? I want a between, and then I say between X and what? Y. Done. Here we go. Okay, and of course, you need to have datums A, B, and C. So let me add them for you here. So here we click on the surface, and we make it flat, maybe with 0.005, right, 5 thou. And we say that this one is my datum A, so you can attach to it a datum like that. Okay, and then for this one, you can say this left surface is my B, which has to be perpendicular to A, right? And this is your B now. And you attach to it datum B. There we go. And for C, maybe you can use this back surface, right? So you can go here and click right there, bring it here, and say this is perpendicular to both A, B, and both A and B, right, like this, and you attached a datum to this one, call it C. Okay, there we go. So now when I say with respect to A, B, and C, it has meaning, and you have in between, and you have unequally disposed and everything, and this is the bilateral. Okay, the last thing we have is all around symbol. So if you want all around, then you put this symbol here, the circle at the corner of your leader, that one. That means it goes, this profile goes all around as opposed to only between 2 points, okay? So if you look on the right side, this is on the entire profile, okay? This is on the entire profile. So if you want, here, I can add to one of them, although I don't want to, but if I want, I can add, because here this is in between, but if I want to, instead of between, I can click here and then what? Click on this symbol, and now that means all around, and now I have to get rid of that in between. Okay, so this is all around, and that is what in between. So let me get rid of that all around. I just wanted you to see what all around is, but I would rather keep it like this for now. Okay, so hopefully this video was useful to you, and I'll see you in my next lecture. Thank you.